let's look at differentiation. Differentiation is about changing y into dy dx. So we will learn formula to change y to dy dx. So this process is called differentiations. Okay, so before we start with differentiations formula, so there are something else which is called limit. So that's why over here at the first subtopic 2.1, limit and its relation to differentiations. Okay, so we learn limits first because later differentiation involve limit. Okay, limits is kind of easy. So limit, let's see the notes here. Okay, I zoom in a bit. Okay, so as you can see here, the LIM stand for limit. Limit. This is the short form. So when x, we just call it like this. When you see an arrow, we say x approaches A. X approaches A. Then what to do is you just need to substitute A into X. Substitute A into X. Then you get FA. FA, if FA is defined. If FA is defined. So they are trying to tell you that, let's say for example, let's say I have limit x approaches 2, then 2x plus 3. Okay, so what to do is we just need to substitute 2 into x, and then we will get 2 plus 3, then we get 7. So this is how we do limit. Okay, so we look at the next one. If FA is not defined, find the limit by observing the trend in the values of fx. Okay, so sometimes you put 2 inside here, it is undefined. Okay, it is undefined. So let's say another example. Limit x approaches 1, x minus 1, x squared minus 3x plus 2. Okay, so sometimes you have this. What to do is, if you use the same method as in number 1, you put 1 into here, here and here, so it becomes undefined. Okay, it becomes undefined basically because you put 1 at the bottom, 1 minus 1 is 0. 0 at the bottom, that means something divided by 0 is undefined. So cannot. So if you cannot substitute straight away, then you have to do something like this. Okay, you have to do something like limit x approaches 1, factorize the quadratic, x minus 2, x minus 1, x minus 1, cut away. Okay, so after you cut away x minus 1, now we can substitute. So we can substitute 1 into x. So we will get 1 minus 2 equal to negative 1. So if you see my working, right, I keep writing the limit until when I substitute 1 into the x, and then I don't need to write the limit. Okay, now let's see the example over here. Okay, so let's see part A. Part A. Find the limit value of each of the following functions. Okay, so we have A. Limit for this. Okay, so the thinking process is just like this. You try to substitute inside. If you can do it, just go ahead. So for this case, yes. 2 plus 5. 4 plus 5, 9. So finish. Now B. Infinity. X approaches infinity. Infinity means it is a very big value. So you put a very big value here. 1 over 2 to the power of infinity. 1 over 2 to the power of infinity. Okay, so maybe you feel like 1 over 2 to the power of infinity, I don't know what value. Of course, you can just try with your calculator. Okay, so how to try with calculator? You just, let's say for example, you try 1 over 2 to the power of 1 million, any big power. Okay, you can just try with 1 million, for example, half to the power of 1 million, and then the calculator will show us 0. So it's equal to 0. If you can't see the number clearly, right, you try an even bigger value. If 1 million is not enough, then you try 1 billion. You put 1 billion inside, half to the power of 1 billion. Then the calculator will show you what value you will get. So that is how we handle the infinity. Okay, now we look at C. For C, our problem here is if you put 1 into here and here, for the top one, 1 minus 1, 0. 0 at the numerator is not a problem. But if you put 1 at the bottom, 1 square minus 1 is also 0. 0 at the denominator is a problem. It is undefined. Okay, undefined. Yeah? So when it is undefined, you don't substitute first. We do something like our question here. Yeah, do something like this. Factorize the quadratic so that you can cut away the one that make the fraction undefined. You know, the one that make the fraction undefined is x minus 1. So we can just do something similar on this case. Okay, I'm not sure whether you remember this formula or not. I just write down first. When you have a square minus b square, then you can change it to a plus b, a minus b. Factorize it. Okay, so we do it at the denominator. So the denominator is basically x square minus 1 square. So you can change it to x plus 1, x minus 1. Okay, then you can cut away the x minus 1, which make the fraction undefined. Okay, now after you cut away, we have 1 over x plus 1, and then we can substitute 1 into the x. And when you substitute, no need to write the limit anymore. Then you get 1 over 2. Okay, so that is the answer. Okay, so altogether we have 3 situations. From the 3 examples here, we have 3 situations. So the first situation is you can substitute straight away. The second situation is it is infinity. You need to try with calculator, try a big values to see what happens to the fractions. And then the third situation is you substitute and it make the fraction undefined, so you need to factorize and cut away. So basically we have 3 situations. Okay, so if nothing happens, then you just substitute straight away, or else you consider this way and or this way. Okay, so this is limit. Now let's move on. We will practice the question here later. Let's look at the next page. Okay, so on the next page, you know, just now at the beginning of the chapter, I said differentiation is changing y to dy dx. This is differentiation. Okay, so now they start with something which is known as differentiation by the first principle. Differentiation by the first principle is the basic way to do differentiation. Okay, so let's see how. Let's look at the note first. Given y equal to fx, let point A take coordinate xy. So which is this point? Xy, this point. Okay. Y equal to fx is the curve, which is this curve. Okay. We have a curve, we have a point, and B become x plus delta x, y plus delta y. Okay. So maybe you're wondering, what is delta x? Delta x. Okay, I write down first. This is called delta x. Delta x means small increment in x. Small increment in x means it increases a little bit. Let's say, for example, let's say x is 2, and then delta x may be 0.1. So increase a little bit. 2 plus 0.1 is something like that. Increase a little bit. Small increase in x. Okay, so delta y is just similar. Small increase or small increment in y. Okay, so let's look at the graph to understand it. Okay, you see, you have point A here. You increase the x a little bit, so you go to the right a little bit, then to get the point B with the new x coordinate x plus delta x. So the y is here, you increase the y a little bit, so it will make the point go up a little bit, y plus delta y. Okay, so increase a little bit on the x and increase a little bit on the y. So it will change it to a point on the curve, another point on the curve, which is a little bit away from the curve. Okay, now you have 2 points now. Okay, you have 2 points. What we need to do is, okay, let's see the information here. The curve is y equal to fx, and you have point A and point B, both lie on the curve. You can see both lie on the curve with the function fx. Okay, now you want to find the first derivative. The first derivative is dy dx. So dy dx is called the first derivative. So they are trying to tell us how to find the dy dx, which is known as the first derivative. Okay, so the first derivative of function y equal to fx is, this is the formula. You see, we have to use limit. You want to find dy dx, you have to use this formula. Limit delta x approaches 0. You know your delta x must be a very small x value. So that's why it is here. The delta x is very small until it is very close to 0. Delta x approaches 0 means very close to 0. And then delta y over delta x. So how to use this formula? Of course, I'm going to show example. Okay. This formula, I talk about it later. It's the same idea, but they use fx for this. Y, you use this. You know, y after differentiation is dy dx. Okay. This one I explain later. So I start with this first. Let's see how we use this formula. When you use this formula to find dy dx, we call it differentiation by the first principle. Okay, now let's see. Let's see how I work it out. Okay, so first of all, we have y equal to 3x squared plus 4. Okay, y equal to 3x squared plus 4. Now, what to do is, I want to increase a little bit on my y and increase a little bit on my x. Okay, increase a little bit, as in the diagram shown here. you have xy, you want to increase a little bit, so the x become x plus delta x, the y become y plus delta y. Okay, so we will do it like this. The y on the left become y plus delta y. Delta y. The x become x plus delta x square. Okay, plus 4. Okay, you see what I did here? I am changing the y to y plus delta y. I am changing the x to x plus delta x. The rest I just write back. Okay, so make sure you get the idea over here. Changing y to y plus delta y, changing x to x plus delta x. Okay, so I want to increase a little bit on my x, I want to increase a little bit on my y. Okay, so let's say more example. I just put at the side here. If you have y equal to 3x, okay, let's say another one. Okay, let's say 4x squared minus 3x plus 5, quadratic. And then the first step, right, you do like this. Your y change to y plus delta y. Your x change to x plus delta x. Then there is another x there, change to x plus delta x. Then plus 5. Okay, so we do like this. So you can see the idea is basically changing the y to delta y, changing the x to x plus delta x, and the x here, x plus delta x. Okay, so this is the second steps. The second step. Okay, so after you do so, we have to expand. Because we have a power 2 over here. As you can see, we have a power 2, we need to expand it. Okay, so when you expand, right, okay, let's do a quick revision on the formula of expanding this. You know, if you have a plus b power 2, it will become a squared plus 2ab plus b squared. If you are not familiar with this way, right, you just use two brackets. You just do like a plus b and then a plus b again. You do like this. If you are not familiar with this, you do like a plus b, and then you times, and times. You will still get the same result. So if you can be fast, then my suggestion, a plus b power 2 straight away, this one. Okay, so it's up to you. So let's say you can be fast and you can take this straight away. Take the blue color formula straight away. Okay, so this is my x squared, followed by, you know, 2ab, 2 times x times delta x. So we get 2x delta x. Okay, so they cannot combine. The x and the delta x here cannot combine. So just leave it like this. And then b squared, right? Delta x squared plus delta x squared. And then plus 4. So what happened is I expand the bracket here. And then I get a squared plus 2ab plus b squared. Okay, so after we do so, then we call it equation 2. You see, they give us the equation here. You call it equation 1. Then you change it to y plus delta y, you change it to x plus delta x, expand, and equation 2. Okay, let's say I don't want to call it equation 2 first. I simplify a little bit first. Okay, I simplify a little bit. I can do a little bit like this. I can multiply 3 into the bracket to get 3x squared, 6x delta x, 3 delta x squared plus 4. Okay, after I simplify, I call it equation 2. Okay, so I have equation 1 and equation 2. What we need to do is, I tell you the general idea first. We want to get delta y over delta x. This is what we want. We do this so that we will get delta y over delta x. Okay, let's see how. Okay, now we do equation 2 minus equation 1. Okay, what is the reason behind it? When we do equation 2 minus equation 1, then we can cancel off the y and then we get delta y. We want delta y over delta x, by the way. Okay, so minus delta y equal to, okay, so imagine when I minus, right, left hand side, this minus with this, the y cancel off. Right hand side, I have this one minus with this one. Okay, imagine okay, let's say I just make a circle here. This one minus with this one. So when I minus, whatever that can cancel off, I just cut it off straight away. 3x squared minus 3x squared, no more. 4 minus 4, no more. Okay, so what remain is this and this. So I still have 6x delta x plus 3 delta x squared. So after I minus, this is what remained. Okay, then don't forget our direction. We want to get delta y over delta x. Okay, so now we have delta y. To get delta y over delta x, we divide by delta x on both sides of the equation. Okay, we divide by delta x. Then we get delta y over delta x on the left. On the right, it is reasonable also. 6x delta x divided by delta x, only 6x remain. 3 delta x power 2 divided by delta x, then we have 3 delta x. So we get delta y over delta x by dividing. Now, once you get delta y over delta x, we want to find first derivative, we want to find dy dx. So we use this formula now. We use this formula. So let's say I write down the formula. You want to find dy over dx, we use this formula. I just write down the formula straight away. Now I substitute the delta y over delta x, which is this thing. I substitute over here. Substitute over here. Okay, now it becomes 6x plus 3 delta x. Okay, so it's just substitutions. And now it is a limit question now. So when we do limits, right? If we can substitute delta x with 0, we just go ahead. Unless it's undefined, then we need to try to simplify it and substitute afterwards. For this case, no problem. You substitute delta x with 0, no problem. Just put 0 here, no? Delta x put 0. Then, okay, so let's say I work it out here. dy dx equal to, okay, I'm going to substitute delta x with 0. So when you are going to substitute, no need to write the limit anymore. So straight away, 6x plus 3, 0. The delta x becomes 0. So dy dx equal to 6x. Okay, so that is the end. We get the first derivative. So quite many things to do here. I will let you practice afterwards. Let's see one more situation. Our last situation. Okay, which is B. B, okay. So for B, fx equal to 5x minus 2. If they give fx, we have to understand it in this way. if you are given with y, differentiation will change it to dy dx. As you can see in our example here, you see at the beginning it is y, then you keep doing, then you get dy dx. So y to dy dx is called differentiation. But if they give us fx, then we just need to take it like this. If you are given with fx, you do differentiation, then you will get f prime x. F prime x. So f prime x is what? F prime x is also the first derivative. It is the same thing. The same thing. It's just a different way to write it down. Different way to write down. Okay, so we don't write dy dx, we write f prime x. F prime x. So this is prime. Okay, so the formula is just more or less the same. Let's take a look. We compare between this formula and this formula. Okay, it's more or less the same. Okay, first we have fx plus h minus fx. So it means what? It means, what is h, by the way? H is same with delta x. Same with delta x. Same with delta x. Okay, so you see the delta x become h already. So h is delta x. So that means if you feel like can I use delta x or not, I don't want to use h, so that it is not that confusing. I can actually. You can use delta x. You can use this form where the h becomes the delta x. It is okay. Okay, now I use graph to explain on what is this. Okay, so what happened is this form over here is actually gradient, which is y2 minus y1 over x2 minus x1. Okay, so you see how come it is gradient. Okay, let's see. You have point A, xy, xy. Okay, so since they don't use y, they use fx. You see y is fx basically. They are using fx now. They don't want to use y. Okay, so I just change it to a x fx. So I don't want to use y, I use fx. Okay, so that's it matches with what we learned here. Okay, so they are using fx. They don't use y. Okay, then from what I explained just now, you need to increase a little bit to your x, become x plus delta x, and the y will increase a little bit also. But this time, right, we write like this. When you increase a little bit to the x, the y will increase a little bit in this way. Okay. So for example, let's say this is 2. Now you increase a little bit, it becomes 2.1. From 2, it becomes 2.1. Okay, so now you want to find a new y, right? You just need to substitute 2.1 into the function. And then you get the y. Okay, you substitute 2.1 into the functions given. Then you get the y. So that's why I write like this. That means you have to substitute the new x value into the function, then you will get the new y value. Okay, so it's a little bit complicated. I put values. so that you can easily imagine it. So let's say A is 2, 5, and this is y equal to fx. Now your x increase a little bit, become 2.1. Then what is your y? Your y is, you substitute 2.1 into the function, into this function, you count, and then you get the new y. So that's why they write like this. Okay, they write like this because it's something like that. Okay, so now you have 2 points, point A and point B. So this is x1, y1, this is x2, y2. You use gradient. I use gradient. Okay, based on the gradient formula, y2 minus y1, right? So y2, this one, minus this one. So you can see it here. y2 minus y1. At the bottom, x2 minus x1. x2 minus x1, they simplify and get this. Imagine x plus delta x minus x. The x cancel off. Only delta x remain. Only delta x remain. So that's why the bottom is just delta x, because it's x2 minus x1. It is gradient. Okay, so example, let's see. We see B here. So they give us fx equal to 5x minus 2. I call it equation 1. When you do this question, right, you try to compare with left hand side, more or less the same. Now the x, you change to x plus delta x. The fx, you change to fx plus delta x. As you can see in the graph, the x, you change to x plus delta x. The fx, you change to fx plus delta x. Okay, so let's do that here. The fx on the left, we change it to fx plus delta x. The x, I change it to x plus delta x minus 2. Okay, so you can see 5x minus 2. The x become x plus delta x. The fx become fx plus delta x. Okay, now expand. 5x plus 5 delta x minus 2. Fx plus delta x. Okay, so what we need to do now is we want to get this form. In order to get this form, you see what we do just now? We minus equation 1 with this equation 2. When you minus 2 minus 1, what happens is fx plus delta x minus fx. This is what happens on the left. Okay, fx plus delta x minus fx. And on the right, what happens is 5x plus 5 delta x minus 2 minus this. So you get this. Okay. Same with this one actually. If you observe properly, right, we are doing the same thing. 2 minus 1. This is 2 minus 1 only. This is 2 minus 1 also. Left hand side, this minus this. It's just that this cannot cancel off, Not like this. This one they can cancel off. This minus this, the y can cancel off. Right hand side, this minus with this. I write down everything and I cancel off later. Now I cancel off. 5x minus 5x, no more already. Minus 2 minus minus 2, no more already. So only only 5 delta x remain. So we want to get this form, as you can see here. We want to get fx plus delta x minus fx divided by delta x. So that's why I same with this one, divide by delta x. So yeah, same. Divide by delta x. So when you divide by delta x, basically 5 delta x divided by delta x, we get 5 only. We get 5 only, huh? We divide by delta x. So after doing so, what happened then is we already get this form. We put limit to it. Okay, we put limit. Okay, so that means I'm using this formula now. F prime of x equal to limit delta x approaches 0 and this one. Okay, so I continue everything over here. Limit delta x approaches 0. I write down the formula. Fx plus delta x minus fx over delta x. So this complicated fraction, we already found it. It is 5. So limit delta x approaches 0, 5. And now you have to change, you have to substitute delta x with 0. But there is no delta x for us to substitute. In that case, you can just write back 5 straight away. So that is f prime of x. So finish. So this is all about first principle.